The universe's ultimate monsters. We're talking about objects with gravity so intense they literally swallow light, warp the fabric of time, and have the power to shape entire galaxies. They are, of course, black holes. And in this explainer, we're going to peer right into the abyss to really get what they are, how they work, and how on Earth we hunt for things that are, by their very nature, completely invisible.
So let's just start with the central mystery, right? Imagine a force so powerful, so absolute, that nothing, and I mean nothing, can escape its grip. Not a planet, not a giant star, not even light itself, which is the fastest thing in the entire universe. What could possibly be that strong?
Well, the answer is a black hole, but it's not really a hole like you'd think of one. It's a place where a tremendous amount of matter has been squeezed into an impossibly small space. This creates a gravitational field so powerful that it basically becomes a one-way trip. Once you pass its border, there is absolutely no coming back.
Okay, to really wrap our heads around a black hole, we need to look at its basic parts. The best way to think about it is like we're mapping out the edge of a giant cosmic waterfall, a point where the river of space-time itself just plunges into nothingness.
First up, the most famous part, the event horizon. Now, this isn't some physical surface you could, touch. It's an invisible boundary, a threshold. It is the point of no return. If you cross this line, you're caught for good. The gravity becomes so extreme that it would stretch you into a thin strand of atoms, a process scientists have colorfully named spaghettification. It's also the edge of our knowledge, because no information can ever escape from past this point.
So, what happens if something does cross the event horizon? Where does it all go? Well, it gets pulled toward the singularity, the true heart of the black hole. This is a point of almost infinite density, where all of that mass is crushed into a space smaller than a single atom. And right here, everything we understand about the universe, space, time, all the laws of physics, it all just breaks.
Now, here's the key thing. Not all black holes are created equal. Scientists have theories about a bunch of different sizes, but they generally fall into two main categories. You can kind of think of them as the common street-level thugs and then the colossal crime bosses of the cosmos. So let's meet these two titans.
On one side, you've got stellar black holes. These are born when a single, massive star runs out of fuel and its own core collapses under its weight. They're what you might call small, maybe 10 to 20 times the mass of our sun. And then you have these supermassive black holes. These guys are the absolute giants. We're talking millions or even billions of times more massive than our sun. How they got so big is one of the greatest puzzles in astronomy, but we know they're the anchors at the center of almost every big galaxy, including ours.
And you might think these stellar mass ones are pretty rare, but get this. Astronomers estimate there could be millions of them right here in our own galactic backyard, just wandering silently and invisibly through the Milky Way. I mean, that is just a staggering thought.
And speaking of our backyard, this isn't some distant, abstract concept. We are living in a galaxy that is organized around one of these titans. That's right, the Milky Way, our home, is constantly spinning around a supermassive black hole at its very heart.
So just how big are we talking for our galaxy's black hole? Well, it's called Sagittarius A star, and its mass is equivalent to 4 million of our suns. All of that matter, all of that unimaginable gravity is packed into one central point that our entire galaxy revolves around. It's just incredible.
Okay, so this raises a huge question, right? We know that 4 million solar mass monster is there, but if it's truly black, if no light can escape it, how in the world do we know? How do you see something that's literally invisible? Well, the simple answer is you don't. Instead, you look for the chaos it creates, the fingerprints it leaves all over its neighborhood.
Scientists have two main ways of doing this. First, they look for something called an accretion disk. See, as gas and dust and even whole stars get pulled in, they form this spinning, superheated whirlpool of matter. All that friction makes the disk glow incredibly brightly, so brightly we can see it from billions of light years away. And for the supermassive black holes, this process can create something even more dramatic: quasars. These are colossal jets of energy and particles blasting out from the black hole's poles at nearly the speed of light, and they can actually outshine entire galaxies.
You know, black holes weren't something astronomers just stumbled upon one night. For decades, they were just a ghost in the machine of mathematics. A prediction so wild that a lot of people, including Einstein himself, thought it couldn't possibly be real. So how did this mind-bending concept go from a theory on a page to a confirmed reality? Well, it's like a cosmic detective story.
It all started back in 1916.
Just a few months after Einstein published his groundbreaking theory of general relativity, a physicist named Carl Schwarzschild used those exact equations to figure out that if you squeezed enough mass into a tiny enough space, gravity would become unstoppable. But for a long time, it was just a theory. It took another 55 years of searching until 1971, when astronomers studying a star in the constellation Cygnus realized it was orbiting an invisible partner. And that was it, the first confirmed black hole.
So you see, these objects are so much more than just cosmic oddities. They are fundamental engines of the universe. They literally bend the fabric of space and time, they play a huge role in how entire galaxies evolve, and they continue to push the absolute limits of science and, of course, our own imagination.
And that really brings us to a final, pretty humbling thought. We can't see black holes directly. We can only see the wake they leave behind as they move through the cosmos. It really makes you wonder, doesn't it? If these incredible cosmic giants can hide in plain sight, what other mysteries are still out there, just waiting for us in the dark?